So we have the last short paper talk in this session on atomic condition coverage analysis by Sangharatna, Godboley, Radha, Krishna and Ritesh Kumar from IIT Warangal. Sangharatna, please connect and get started.
That's all about coverage analysis we should do. Sorry for the delay. I'm Sangharatna Godboley, and I'm going to present our contribution, atomic condition coverage analysis for structured text-based programmable logic controller, PLC, and along with my team, Professor Radha Krishna and Ritesh. Since we are running out of time, so I will be just telling my idea what exactly we are trying to do. So programmable logic controller is sort of your hardware, and to write software for that, we use structured text. Now the thing is how we can test it. So in this particular contribution, we want to tell that how we can translate from structured text to certain high-level language. We have used Python, and we can do the code analysis. So the code analysis part that actually we are trying to do with some insertions of the targets, and that's what actually we have done. So proposed method evaluate structured text program using Python, and condition coverage, why we have chosen, because it's like very initial coverage criterion that we can consider for white box testing. And we have planned to go till, let's say, more complex, that is MCDC and multiple condition coverage. But for this contribution, we want to tell that how we can get the condition coverage for structured test. So we annotate a structured test with some artificial errors. Usually we say assert 0, sometimes division by 0. So we have taken division by 0 here. And then we generate the Python code. And then we use some libraries to get back the runtime errors, and we say that if that error is reachable due to that condition, then that condition is covered. Why it is important? Because these are the failures. Like some problems actually we have found. Let's say in 2006, some round ferry and some cyber attacks happened, and the PLC got actually failed, and Hatch NPP and Natanz SPP. So these are some, let's say, case studies that actually we mentioned in the paper as well. So just you can look at how exactly PLC looks like. It's just not like writing in sentences. A lot of things got involved. Let's say this is the PLC block diagram. If we want to represent the structure, let's say this PLC in the structure test, a lot of things actually required to be there. So we have used Entler for some translation, and it's a tool that it's a parser generator used for reading, processing, and interpreting text files. It generates language parsers based on formal language called grammars, and it also gives us the AST, that is abstract syntax tree, and we have used all those things. In related work, we have seen some work actually people also did. For example, PLC Verif, Arcade.plc, and PLC Studio. So there are some work, but we are focused on how we can get condition coverage. So this is the main idea, and you can see the flow that we consider the structured test program, and we insert division by 0, and we find wherever we have the relational operator, okay, there we, in that scope, we insert this runtime error. And then we generate like parser visitor using Entler, as I said. Then we try to, let's say, translate the program in Python, perform that runtime analysis of the converted code, and then the coverage that we are getting, wherever we get the lines got covered, and we hence say that condition coverage is achieved. So I'm just skipping. So this is what PLC structured text grammar that actually generate, and for this work we have not done a full experiment. We are still in some investigation that how we can achieve good. The idea that actually we wanted to show here, let's say the PLC structured text looks like this, and it has relational operators, and we focus to do in that. And this is the AST for the code and converted Python code, and we use coverage for the coverage library for the Python, and we finally say that, okay, if the condition is true and if that division by 0 can be detected, then we claim that that is reachable. If not, then that is not reachable. And test cases we are writing to play the program. So the coverage that actually we get in this way, like what is the percentage score out of how many lines. So the good thing that actually we should do now is more and more ST programs that actually we have to, let's say, check, and rigorous study is required. Also, along with condition coverage, we also require to go for some higher or stronger coverage criterion like MCDC, because PLC is mostly used in some embedded system, and wherever the critical safety applications are there, for example, nuclear reactor and avionics, so there MCDC is required. But I have not found much work that MCDC for PLC, so that is our future work. Yeah, that's the conclusion. So this is sponsored by the project grant. Any question? Because, yeah. That is what the idea actually in the flow diagram. This is the step. That is what the entire idea actually.
Yeah, so what is the benefit, like while converting into Python, what is the exact benefit we are getting?
So we can say that PLC, which actually we are writing, okay. So here you consider Python is one intermediate code. Ultimately, we want to achieve code coverage for PLC, and we are getting in that way. We know for Python, it's very mature techniques we already have for condition coverage, MCDC, etc.
We cannot directly do it on structured text?
That's what the idea we are proposing. So very less work, and we are focusing on condition coverage.
Okay, so if it is converted to Python, you can use already existing methods, is it so?
We can, but we need to see the statements. So it's still it's progressive work, that what I'm saying, that how much effort we have put for this translation. It is like structure test we got, and somehow we are getting this Python using this entler and stubs. Okay. So all this idea that you can put what you have for Python, but ultimately the goal is to say that you are achieving condition coverage or some MCDC for PLC. So we are considering Python as intermediate code.
Are you considering PLC specific behaviors for this work?
Specific behavior?
Yeah, periodicity.
No. We are, so as you can see, we are taking a piece of code which represent programmable logic controller, which is used in hardware, and we want to achieve the condition coverage. So that part we have not considered, so we definitely can look at. So yeah, it requires some more investigation.